Hello everyone, how are we doing? Welcome back to another Wi-Fi Sheep tech video. This is part 2 of the CUB CRT monitor repair. This is a CUB monitor for a BBC Micro. Those of you who watched part 1 end of last year will know that this has a few problems. It wasn't displaying red on the screen and we identified it as a logic fault. So today, and it's February now, it's coming up sort of midway through February, I've only just got back to this. Today we're going to try and take the PCB, which is the board down here, out and see if we can actually resolder components. Speaking of components, what did you get for Christmas? Because I got, so we can pick these up on camera, there we go, 3 new compatible, or hopefully compatible, transistors, and the plan is we're going to take the old ones out, swap with these. I'm probably going to do all 3 just because, well, I can, and if one goes there's nothing to say the others wouldn't fail, and we're hoping above hope that that's actually it. Now this monitor's not been powered up since the last demonstration, so it's been off for a year or so, but I've got to get inside and disconnect bits, potentially high voltages. So I'm going to discharge the CRT, and there's about a zillion and one YouTube videos of how to do this. I'm no expert on doing this. I've done it once before, and it was the first time ever, and that was actually with this monitor when I was in the garage trying to get it to work. So first thing we're going to do is going to try and take all the voltages out of it. Now there probably isn't any voltage in it, to be honest with you, but I don't want to take that risk. Usually go a little bit overboard on the safety. Rubber gloves for starters, because not necessarily necessary, but is that a word? Necessarily? Yeah, it probably is. Yeah, so that'll do for that. What we need to do is get a decent, solid flathead screwdriver, good insulated end, and we get a crocodile clip or alligator clip, depending on what you call it, and we're just going to clip that to the end. And then we make sure that the other end is actually tapped to the earth or the chassis of the unit. Now ideally, as an extra safety, it would be possible to plug this into the mains but not powered on, because that would connect the earth. British plugs have a 3-pin system, so they have an earth plug. I don't think that's going to be necessary, as I kind of know there's no voltage in this, but because it's high voltage you just don't want to take that risk. I should point out, unless you're really confident in doing this, don't do it, because up to 2000 volts can sit on a CRT. It's a bit of a nasty nip, to say the least. So a classic one of these, don't try this at home. But, okay, so we've been connected. What we want to do is, this is the anode cap, and just going to poke underneath. Careful not, there's an insulation lining around this area, which is, you can't really see because it's transparent and as thin as anything, but you don't want to be scratching the surface. And we just want to touch, there's a metal pin inside the cap here, and we just want to touch that. You sometimes get a spark and you know it's discharged. There's no voltage in this, so that's definitely nothing in there. So what I want to do now is I just want to take this cap out. Again, I'm being extremely careful. Oh, there we go. And we need to take the cap, which has like a sort of a spring, a claw type link. You can see that. I'll get out of the way. There we are. Claw type link, and actually goes in a small hole here. And what we can do is we can just tap inside the hole and tap. Make sure we are actually safely discharged. Okay, that's that. Yeah, you sit there. Okay, that's number 1 bit done. Because I want to get the board out, I've got to disconnect it, and I think the best way to do that is probably to take the neck board off CRT. It's easier than trying to disconnect all the couplings and cabling, which although theoretically would come out, I've had experience of these sort of soldered clip joints breaking at the board, and I don't really want to be breaking all the clips. So I think we can probably say we're safe enough. I'll take the gloves off. So what we can do is hopefully just take this neck board out. And I had actually, before we started the video, just there we go. Be extremely careful, because if we break anything on the neck board or the CRT, then we are absolutely screwed. Okay. There we go, so that's now off. So I'm going to cut the video in a minute. What I'm going to do is there's two more links down here, which I'm just going to take out. And then hopefully, oh, and also take the earth out. It's earthed on this side as well. Take that earth out. And then it's a clip fitting. We should be able to take the whole PCB out the back of the unit, hopefully. Leave the CRT itself intact in situ, so we don't have to take things like the degaussing ring off or anything like that. So the CRT we know is working, it's just that we need to get to the logic. So I'm just going to do that now, back in a moment. Blimey. Right, okay, we're out. So neck board still attached, anode cap is still here. Being so careful with this stuff because it's just fragile and brittle and dirty and everything. So what we're going to do is, just while we got it out, just carefully give everything a bit of a sweep down. Not that there's an awful lot you can do with this really, but I'm just checking for any obvious signs of anything. The problem is it's just about age. I think it's very, very brittle. God knows we've broken anything else in the process of getting this out, but the monitor wasn't working properly, so it was if it wasn't working it was just junk to me, so it was kind of do or die scenario. Yeah, so what I'm going to do now is we'll get it on the mat, we'll try and get it upside down the best I can, and we'll identify where my fault is and take the transistors out. Okay, PCB is now upside down, or upside down enough. And what I've done is I've just marked here where the three transistors for the RGB are. Having a quick look on the board, I don't see any other dry joints. You never know. It's more a drop in voltage rather than intermittent or no voltage, which makes me think it's a logic fault. That's the back of the IC. Just there, integrated circuitry. It was doing the TTL logic. That's where the jumpers are, or switching between RGB and TTL, and then just above are the three transistors for the red, green and blue signal. So just got my soldering iron, and we'll just have a little probe around just to see if it's possible to reheat. Yeah. Coming quite nice. There we go. So this is probably the most horrendous thing you've ever seen, but just going to see, just take some of the solder off. Not doing it at all well, or at all right even, but there we go. Desolder. So we sort of get an idea where we are at. There we go. That looks to have gone through. Well, what I did with my pliers, just on it out behind me. Just have a quick look, see what that's done. Oh, by the way, you may see I put this board on a piece of bubble wrap just because it's sitting very awkwardly. Yeah, it's still quite secure, so we'll just try that again. It's a very, very slow process, this, so take a bit of time. Shouldn't get any crap on the end of your soldering iron either. Okay, success. The bugger is out. There you are, just grab it on it. There we are. Can we focus on that, I wonder? Probably not. No. But yeah, that's the problem. Tiny little transistor. Hopefully that's the problem. So what we're going to do is we're going to replace it now with another one. So just going to tack it back in the hole and then just put it back in. Got to make sure it's the right way around. There's a flat side, there's a curved side. Yeah, I'm hoping that's it. I'm tempted, and I know people are shouting at me for this. I said I was going to do all three. I might just do the red logic and see if that actually fixes this problem. If it doesn't, it means there's something else wrong. So we'll just get that tacked back in and we'll be on our way. It's now, pins are now in. Probably can't see it that well. I can barely see it as we go actually. So what we'll do is just use a little bit of flux. When people solder, they don't seem to realise you've got to flux things up. So like so, just helps to clean everything. Of course, this will all be using a lead solder originally, but they can't really get lead solder anymore because it's not allowed. So use this sort of pewter replacement stuff, which has a horrible tendency to dry joint. So we'll just make sure there's plenty. That nicely secured in. Always wanted to pick something else to do. You really want to make sure you've got a good contact. So there we go. That looks good. And now what we can do is, well, I'll do the call them tin snips. They're not quite tin snips. They're I'll show you. They're these. There we go. Which are actually used for cutting model railway track. You can actually cut the rail directly, which is fantastic for my other hobby, building model railways. But they're also very good for just taking the edges off things. Well, here's getting a bit blunt actually. Always a case of abusing your tools. There we go. It's looking alright. Okay, I think we will get that back in to the monitor. Pray nothing else got broken in the disassembly. Everything else is looking alright. Yeah. Right, this is going to be the horrible moment of truth. Just taking a piece of B up from the table where we were doing the soldering. So careful with this. Oh, there we go. You can see netboard is still attached. Be so careful not to damage anything else. Now what we need to do is just make sure that any additional cables are just out of the way the best we can at the minute. So I'll just go in there for a minute. There we go. Very, very carefully just offer up the board. best we can back to the chassis. Oh, lovely sound. Wants to be somewhere around there. And we just want to take the anode cap, make sure that's sort of out of the way for the minute. Actually, before we go any further, just one thing I want to do when it's easier to do it. Get me screwdriver. This one's, oh, that one might be better actually. You may remember last time I turned the voltage down, it stopped it sparking. Well, we had a little spark on the screen, so I just want to take the opportunity just to adjust this. Just turn this down just a little bit more. Might have been slightly overvolting. So now we've done that, let's get this in. Okay, now we can start marrying up the clips again. A little bit more. Some of these so easy to come out, and others stubborn as hell. No chance. There's a pain to come out and a pain to go back in, looks of it. Come on. Might come back to that in a minute. Okay. So get the anode cap out of the way, and now we're going to very, very carefully just resocket the neck board back onto the tube. There we go. Anode cap. There we go, back on. And that shouldn't be too difficult, just to get this to sit back on its pegs. Oh, there we go. I will make strange sounds until we're back in. And it just clips. Just clip it on 2 for a minute. Go on in 3. There we go, that's back in. Just make sure the net board is back on, which it is. So, alright, there's a cable here, which might be a ground or an earth or something, and that wants to go onto connects onto a plug on the net board, and there we are. So now we'll just reintroduce the back plate. Oh, and of course not forgetting, most importantly, to put the earth back on, which is here. I am hoping above hope that this works now. Who knows? We'll find out in a minute. Okay. We're back together, I think. We're all earthed up. The Acorn Electron is on, it is connected. This is the first time this thing has been on. Let's see what happens. So far, so good. Well, I've not killed it. That doesn't look very white though. That's not fixed it. That's not fixed it. That's disappointing. I think we'll have to do another, get the multimeter out, just do another test, just to see what's happening. Could be a faulty could be now be a faulty IC. Let's try changing the jumper over again. Yeah. Oh, right. Same problem as before. I must be the IC chip. Must be the IC chip. Okay, I think we're going to have to leave that there for the moment. So I think that's going to be a part 3 where we try and figure out how to get this damn thing to work again. The good news is it looks like it survived its ordeal at the moment. So we'll, yeah. I don't know. I'm just thinking now, which isn't good for a YouTube video. Me just thinking. Yep. Okay. Right, we'll leave that there for now, and yeah, I'll update if we manage to do anything. Thanks for watching.